Okay. Column 1 with one end fixed and other end hinged. So write down. Consider column 1 EB of length L fixed at A and hinged at B. Hinged at B. Okay. The critical load at B. Critical load applied at B. Due to critical load, column 1 will be buckle. As shown in figure. Okay. So a little consideration again. Consideration at A fixed end moment due to critical load and balancing for this moment there will be horizontal force, one horizontal force acted at B as shown in figure. Okay. As shown in figure. Okay. So moment due to critical load, so P it is, you can write down, P it is critical load. P it is critical load. Yet it is MA, it is fixed end moment at A. And Y it is deflection due to critical load. Okay. And H it is horizontal force. At B. Horizontal force at B. Okay. So moment at x1. Moment at x1 means here it will be moment. Okay. Here it will be moment. So moment at x1 is equal to, that is M is equal to So first of all, this due to this one h distance, we know force into perpendicular distance. So this distance it is L minus x. Okay. So total it is L and up to here it is x. So L minus x. So h in bracket L minus x, x, then minus p into y, Okay. So this h, it is rotating about the x dash, it will be clockwise direction, and p, it will be rotating about this one, it is anti-clockwise direction. Okay. So that's why it will be take minus value. Okay. So now apply the Maculus method. ei d2y by dx square d2y d2y divided by dx square divided by dx square dx square is equal to h in bracket L minus x minus p into y Okay. The general solution of above differential equation is, so first of all, ai d2y by dx square is equal to, will be h in bracket L minus x minus py minus py. Okay. So just make it is, take minus p by a, it is in right side. ei d2y by dx square d2y by dx square dx square. So minus py to be the right side plus py is equal to h in bracket L minus x. Okay. So divide ei on both side, Okay. It will be get d2y divided by dx square divided by dx square 2y by dx square, then plus p by ei p by ei into y is equal to h in bracket L minus x divided by a divided by ei divided by ei. Solution of the above differential equation is, the solution of the general solution of so general solution of differential equation is differential equation is you can write down, it is y is equal to a cos of x root of p by a ei P by A root of P by A bracket close plus B sine of n bracket x root of P by A x root of P by A P by A P by A P by A bracket close plus H by P plus H by P plus H by P. Okay, so this is general equation of H. So this one it is H in bracket L minus X H L minus X. Okay, so now this is general solution of the differential equation. Okay, so now apply boundary condition. So first boundary condition when x is equal to 0, when x is equal to 0, so y is equal to 0. So this one it is equation number 1. Put in equation 1. Put in equation 1. Equation 1. Okay, so y is equal to 0, then plus a cos 0, it will be cos. So when put x is equal to 0, it will be total terms, it will be get 0, then plus sine 0, it will be 0, then plus h l x is equal to 0, it will be get only here h by p. So a is equal to, it will be a is equal to minus h by p. A is equal to minus h by p minus h by p minus h by p. Okay, so this one it is, I will write here a is equal to minus h by p. Okay, so differentiate with respect to x, equation 1. Differentiate with respect to x to equation 1. Okay, differentiate with respect to x, equation 1. Okay, so we required equation 1 right below this line. Okay, so differentiate with respect to x, equation 1. Okay, equation 1. So y it is dy by dx, so minus a into root of p by a, so y root of p by a, so cos of root of p by a, it will be sine of root of p by a, root of x p by a. So again we will take derivative of x root of p by a, it will be get root of p by a. Okay, so now cos, it will get sine root of p by a. root of P by A. P by A. Root of P by A. Root of X. X root of P by A. Root of P by A. Root of P by A. P by A. P by A. Bracket close. Plus B root of P by A. Root of P by A. Root of P by A. P by A. Root of P by A. Sine. Now cos. Sine derivative of cos. Cos in bracket root of P by A. X root of P by A. X root of P by A. Root of P by A. P divided by EI. EI bracket close. Bracket close. Then now differential with respect to just it will be solve this one bracket HL by P, then minus HX by P. So HX by P it will be derivative be only H by P. H by P minus H by P. Okay, minus H by P. Minus H by 1. So put then this one it is equation number 2. So apply the second differential, apply the second boundary condition. Apply second boundary condition. Second boundary condition. Boundary condition. When x is equal to 0, when x is equal to 0, so dy by dx is equal to 0, comma dy by dx is equal to 0. Dy by dx is equal to 0. Dy by dx is equal to 0 in equation 2. In equation 2. Okay. So dy by dx will get 0. 0 is equal to. So this term when put sign 0 it will be get this term it will be get 0. Then b into root of p by a. 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 Then cos 0. Cos 0 it will be 1. Then minus h by p. Minus h by p. H by p. Minus h by p. H by p. So b is equal to it will be get how much here? So again it will be simplify this equation. So b into root of p by a. Root of p by a. Root of p by a. P by a is equal to h by p. P by a. P by a is equal to h by p is equal to h by p. H by p. H by p. Okay. So b is equal to, now b is equal to B is equal to, it will be get B is equal to H by Pi, H by P, H by P root of EI by P, root of, it will get, when left side it will be EI by P, EI by P, EI by. So put A, B value in equation 1. So put A and B in equation 1, in equation 1, in equation 1. Okay. So just write down in equation 1, y is equal to A value, it is minus H by P, minus H by P, minus H by P, minus H by P, minus H by P into cos of in bracket x root of P by A, x root of P by A, x root of P by A, P by A, P divided by EI, bracket close, then plus B is equal to, it is H by P, H by P, H by P root of EI by P, root of EI by P, EI by EI by P into sin x root of P by A, x root of P by A, root of P by EI, P by EI, okay, x root of P by A. So then plus H by P L minus X, H by P L minus X, H by P in bracket L minus X, L minus X. Okay, so this is equation number 4. Okay, and on this one it is equation number 4. So apply the next boundary condition when boundary condition when x is equal to L, when x is equal to L and y is equal to 0 in equation 4. Put in equation 4. Put in equation 4. Put in equation 4. When x is equal to L, y is equal to 0. So 0 is equal to minus H by P minus H by P minus H by P just you can apply here. Okay, so when x is equal to 0, So y is equal to this term, it will be get 0. 0 is equal to minus h by p minus h by p h by p. So in bracket cos of x, it will be L. X, it will be L. So L root of p by a, root of p by a, root of p by a, p by a, p by a. Then plus h by p plus h by p h by p root ai by p root ai by p ai by p ai by p ai by p p. Then into sine of in bracket L L L L root p by a, L in bracket root p by a, in bracket p by a, p by a, p by a, p by a, bracket close, plus when x is equal to L, so L minus it will be get 0. So this term it will be totally 0. Okay. So just simplify this equation. Okay. So write down. So h by minus h by t, it will be take left side. So it will be get plus h by p, h by p, h by p into cos in bracket cos in bracket. So this term it actually L root of p by a, root of p by a, p by a, p by a, p by a, bracket close, bracket close, bracket close, is equal to h by p, h by p, h by p, root of ei by p, root of ei by p, ei by p, ei by p is equal to sine of in bracket L root of p by a, root of p by a, p by a, p by a, p by a, bracket close. Okay. So this h by p, this h by p, it will get cancelled. So now, so sine L root p by a, it will be take this one, it is ei. It's take left side. and root ei by pi it will be take left side, and cos l by root p by a it will be take right side. Okay, so you can write down now just this root of p by a. So we'll directly write down equation sine of l root of p by a, root of p by a, p by a, p by a, bracket close, divided by cos, divided by cos root of l root of p by a, root of p by a, root of p by a, p by a, bracket close, is equal to root of p by a, root of p by a. This will root of p by a. Okay, just simplify this equation. So sine by cos it will be tan. Okay, sine by cos it will be tan. So here this equation it will be get tan root of p by a, tan root of p by a, p by a, bracket close. Actually here L it is remaining. L root of p by a is equal to root of p by a, 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 p by a. Okay, so we know that when we can write down tan x is equal to x, when this equation, so it will be wrote x is equal to, it will be 4.5, x is equal to, it will be 4.5. So similarly here also, similarly here also, so actually here we are remaining L, sorry, here we are remaining L, here it is also L. So L root of p by a, root of p by a, p by a, root of p by a is equal to 4.5, is equal to 4.5. Okay, so squaring on both side, squaring on both side, squaring on both side, squaring on both side, both side. So L square root of, so it will be root, it will be get cancelled because of square, p by ei, you get p by a, p by ei is equal to 4.5 square. Okay, so 4.5 square, how much? It will be 4.5 square, it will be 20.25, 20.25. 5. Okay. So P is equal to here. Can write down P is equal to 20.25 into EI divided by L square divided by L square divided by L square divided by L square. So 20.25 you can write down, it will be this one, it will be near to value of 2 pi. Okay, near to value of it will be 2 into pi square. Okay, 2 into pi square value. Okay, so here see here 20.25 is equal to, so I will write down here so 20.25 is equal to, it will be 2 into pi square, 2 into pi square. So pi it will be 3.14. Okay, so this value it will be near to this one. Okay, so you can write down final equation P is equal to 2 pi square 2 pi square 2 pi square EI divided by L square divided by L square divided by L square. So this one it is crippling load when one end fixed and other end it is hinged. Okay, 2 pi square EI by L square. Okay, this one it is Euler's crippling load when one end it is fixed and other end it is hinged.